Welcome to Arid Online Academy. In this video, we're going to consider strong acids and weak acids. So we want to look at the difference or the differences between a strong acid and a weak acid. So by the end of this video, you'll be able to describe the meaning of weak and strong acid. So essentially, we'll be focusing on how to represent the strength of an acid. So let's consider how to represent the strength of an acid. From previous lessons, we have seen that an acid produces hydrogen ion in solution. Therefore, the strength of an acid will be a measure of the extent to which the hydrogen ion is produced. Now, basically, this is what is known as acid dissociation or the dissociation of an acid. So essentially, the strength of an acid is proportional to the ionization of the acid. So when you say an acid ionizes, for example, hydrochloric acid in water, aqueous, if it ionizes, it simply means that it splits into its ions. That is ionization. Okay, so it dissociates into its ion. So the extent to which this hydrochloric acid splits or dissociates or produces hydrogen ion in solution is known as its ionization, and it is in turn a measure of the strength of an acid. I mean, look at it this way. If what makes this substance an acid is the fact that it can produce, let's just focus on hydrogen ion in solution. So its nature is the production of hydrogen ion. So the more hydrogen ion it produces, the more of its nature it displays. So that means, therefore, that we could have a strong acid and a weak acid in terms of the strength of acid. So we could have a strong acid and a weak acid. So if what makes this an acid is the fact that it can ionize, then a strong acid will be one that ionizes very well, that ionizes greatly. While a weak acid will be one that ionizes weakly or partially. So let's use the word partially, that ionizes partially. So this will lead us to the definition of a strong acid and a weak acid. So we'll say a strong acid ionizes completely in solution. What this simply means is that when the acid dissociates, all the hydrogen ion possible would be formed in the solution. So if I have nitric acid dissociating, let's assume that I have 10 of this nitric acid in solution, 10 moles of nitric acid. Mole is a unit of measurement in chemistry. So let's say we have 10 moles of nitric acid dissociating in solution, splitting. I would expect, if you see your acid as a pair, Okay, see as a pair of slippers. This is one part, this is the other part. So if I have 10 pair, 10 pair, let's assume I have 10 pairs of slippers splitting, breaking into two. I would expect to have 10 of one half and 10 of what? Of the other half visible. Okay, so if this is what I have, then I will say everything has completely what? Dissociated. So let's look at a strong acid. We said a strong acid dissociates completely. What does that mean? So it simply means that if I have 10 moles of nitric acid, for example, in solution, when it ionizes, that is, form ions in solution, all the possible hydrogen ion available would be visible in the solution, will be released into the solution. So I will be getting 10 moles of hydrogen ions, and of course I will be getting 10 moles of nitrate ion, 10 moles of nitrate ions. So this means that the acid completely was dissociated. The acid did not hide anything behind while dissociating. All was soluble in the what? In the water. So it completely dissociates. So we say this is a strong acid. So when we talk about dissociation, let's look at another example. I have sulfuric acid. This is sulfuric acid, aqueous. Okay, so I would expect it to break into its various parts. Don't forget, every acid has two parts, the hydrogen ion part and the other negative what? Ion. So I would expect this to dissociate into this. Okay, so for every 1 mole of this, I'm expected to have 2 of my hydrogen here. 2 of this hydrogen is what I've got here, and 1 of this is what I've got here. So we can say that this acid as well completely dissociated. That's completely dissociated, or completely what? Ionized. So a strong acid is one that completely ionized in solution. So let's consider what a weak acid would be. I mean, it will just be the opposite of what a strong acid is. So having got that background, so a weak acid is one, okay, that a weak acid partially ionizes, okay, in what? In solution. What that simply means is that, for example, let's look at uh, ethanoic acid. Ethanoic acid, it's a weak, this is the formula for ethanoic acid, is one of the organic acid. Okay, this is ethanoic acid, it's a weak acid. So what makes it a weak acid? If it dissociates in solution, it dissociates partially in solution. Dissociating partially in solution simply means that it's not going to show, or it's not going to release all the hydrogen ion that it has. Now, when we say all the hydrogen ion that it has, you need to be aware that in this particular compound, not all the hydrogen ions here are replaceable hydrogen ion. So ethanoic acid has only one replaceable hydrogen ion, which is this hydrogen ion here. That is the only one that can ionize. Okay, so but having said that, if I have 10 moles of this ethanoic acid, 10 moles of ethanoic acid, I would be expecting to get 10 moles of the ionizable hydrogen ion, 10 moles of the replaceable hydrogen ion. But not all the 10 moles of the replaceable hydrogen ion would be ionized. So what makes this a weak acid is the fact that out of the 10 moles of the possible hydrogen ion that we could get, maybe only 2 moles will be in solution, and 8 moles remains unionized. 8 moles remains unionized, almost like saying 8 moles remains insoluble, So let's use that word in this context now. remains insoluble, while 2 out of the 10 moles of this ethanoic acid would be soluble. So in a sense, C inorganic acid or C weak acid as acid that are not totally soluble. Let's use that sense of solubility so that you can grasp it very well. Okay, so all the hydrogen ion will not dissociate, will not be ionized. So if they would not be ionized, then they will not contribute to the hydrogen ion concentration that we should get for this particular uh, acid. So that's why they are what? A weak acid. It simply means that they do not give all they have. A weak acid, so in essence, we can say that a weak acid does not give out all its hydrogen ion, does not give out all its hydrogen ion, does not turn all its hydrogen toward hydrogen ion. So having looked at that, a strong acid completely ionized, while a weak acid is one that what? Partially ionized. So you will need to be able to recognize examples of strong acid and what? And weak acid. Examples of strong acid and weak acid. So most organic acids are weak acid. Okay, so your weak acid, if you have to give an example of weak acid, your organic acid, your ethanoic acid, your propanoic acid, these are what? Organic acid. Your citric acid is a weak acid. Okay, your palmitic acid is a weak acid. That's the acid in palm oil. Stearic acid is a weak acid. Lactic acid is a weak acid. These are organic acids. Okay, organic acid because they are found in living organism. Okay, so we also have some inorganic acid that are what? That are weak acid. Example is your carbonic acid is a weak acid. That is H2CO3. That's carbonic acid, is a weak acid. You have your phosphoric acid. Phosphoric acid is a weak acid. H3PO4. Okay, it's a weak acid. So these examples will just be fine. You can explore more examples of weak acids. So strong acid, your inorganic acids, okay, inorganic acids are weak, are strong acids. Okay, your sulfuric acid is a strong acid. Your H2SO4, hydrochloric acid is a strong acid. Your nitric acid is a strong what? Strong acid. So these are great examples of weak acid and what? And strong acid. So let's try to distinguish between strong acid and weak acid in terms of the concentration of the acid, in terms of the strength of the acid, and in terms of the pH of what? Of the acid. Okay, so let's put down very valid point when it comes to distinguishing between strong acid and what? And weak acid. Okay, so at the same concentration of hydrogen ion, if you like, at the same concentration, the stronger, these are clues are very helpful, the stronger the acid, at the same concentration, the stronger acid, we have the lower pH, we have lower pH. Okay, because the stronger the stronger the acid, the more the hydrogen ion concentration that will be in solution, and of course the lower the pH. Okay, the strength of the acid, so let's use diagram to represent that. So if the strength of the acid goes up, is higher, okay, the concentration of hydrogen ion, don't forget this is how we represent concentration of hydrogen ion, will be high, and of course the pH will be what? Will be lower. Okay, remember the pH scale. So another valid point, at the same concentration, the stronger acid will have the better conductor of electricity. The stronger acid, so we can do vice versa. The stronger acid will be the better conductor of electricity. And you should be able to relate this to why substances conduct electricity. Substances conduct electricity because they have mobile ions. So acid will conduct electricity because they have mobile ions. So that simply means that the more the ions in solution, the more the electrical conductivity. So if the acid is strong, that is, the strength increases, it means the hydrogen ion concentration will increase, then the electrical what? Electrical conductivity. Electrical conductivity will also what? Will also increase. This is very interesting and very simple to grasp. Okay, so at the last point we would like to make on this, which would be the third differences between the strong acid and weak acid, would be that at the same concentration and temperature, the stronger acid will react faster with, with solid at the same concentration. So it's very important at the same concentration, the stronger acid would react faster, with, it could be with solids like let's say magnesium ribbon or lumps of calcium carbonate. With magnesium ribbon, or let's say calcium carbonate. We'll consider reactions of acid in subsequent video. So at the same concentration, the stronger acid will react faster with what? With solid. And of course, you should be able to relate this to factors affecting the rate of chemical reaction. The higher the concentration, the faster the what? The reaction. So it is essential for you to know that when they ask you to compare the strength of the acid, it definitely will be at the same concentration for you to be able to make a fair comparison. So you should know that it is possible to have that there is difference between the strength of the acid and the concentration of what? Of the acid. So you could have dilute, it's possible to have dilute strong acid, and concentrated strong acid. The same vein, it is possible to have dilute weak acid and concentrated weak acid. So strength and concentration, okay, differs, but largely a strong acid is a strong acid irrespective of the amount present in a solution. A weak acid is a weak acid irrespective of the amount present in solution. So the fact that a weak acid is concentrated does not make it become a strong acid. So let's quickly summarize what we have learned. So we have learned here that a strong acid dissociates completely in solution, while a weak acid dissociates partially in solution. We have also learned that at the same concentration, the stronger acid will react faster. Okay, the stronger acid, so strong acid, okay, react faster than what? Than weak acid. At the same concentration, Strong acid will have a higher hydrogen ion, okay, present, dissociated or ionized, and of course it will have a lower what? Lower pH than a weak acid. At the same concentration, strong acid will have a lower pH than a weak acid. The lower pH signifies that it's a better acid. Remember your pH scale. Okay, if you go downwards, okay, you are going towards acid. If you go higher pH, you are going towards base. Okay, I'll see you in the next video. Kindly subscribe to my channel so that when I drop new videos, you'll be the first to be notified, and click the notification icon. See you